The lathe is often called the mother of all machine tools because so many other machines evolved from its basic principles. Its function is simple in concept. It rotates the workpiece against the cutting tool to shape it. In practice, however, it is capable of producing extremely precise cylindrical, conical, and even complex contoured shapes. 1.1 Components of the lathe. The main parts of a conventional engine lathe include bed, the heavy, rigid base that supports all other components. Headstock, contains the spindle, bearings, and drive system that rotate the workpiece. Tailstock, positioned opposite the headstock, used for supporting long workpieces or holding tools like drill bits. Carriage, holds and moves the cutting tool along the workpiece. Lead screw and feed rod, mechanisms for precise movement during threading or feeding. 1.2 Lathe operations. Facing, cutting across the end of a workpiece to make it flat and square to the axis. Turning, reducing the diameter of a workpiece to a specific size. Taper turning, producing a conical shape along the workpiece length. Parting, cutting off a section of material using a narrow tool. Thread cutting, producing screw threads using coordinated feed and spindle rotation. Drilling and boring, creating and enlarging holes in the workpiece. 1.3 Safety in lathe operations. Never wear gloves while operating a lathe. Ensure workpieces are securely clamped in the chuck or between centers. Keep cutting tools sharp and properly aligned. Stand clear of rotating chucks when starting the machine. Use chip guards to protect against hot, sharp swerve. 1.4 Measuring and checking work. On the lathe, precise measurements are taken using micrometers, calipers, and dial indicators during the machining process to ensure tolerance limits are maintained. Section 2, Basic Milling Operations. Intro Tone, Technical and Structured. While the lathe rotates the workpiece, the milling machine rotates the cutting tool. This opens up a completely different set of possibilities for shaping materials. 2.1 Types of milling machines. Horizontal milling machine, cutter mounted on a horizontal spindle. Vertical milling machine, cutter mounted vertically, common in most workshops. Universal milling machine, capable of both horizontal and vertical configurations. 2.2 Milling operations. Face milling, produces a flat surface perpendicular to the cutter axis. Peripheral milling, cutter engages the work along its periphery for deeper cuts. Slot milling, producing slots or grooves. Profile milling, creating contoured shapes. Gear cutting, using special form cutters or hubs. 2.3 Work holding in milling. Workpieces are usually secured in vices for small, regular shapes. Clamps and T-slots for larger parts. Rotary tables for circular machining. 2.4 Safety in milling. Always remove the chuck key immediately after tightening. Secure work firmly. Loose workpieces can be dangerous projectiles. Keep hands away from rotating cutters. Wear eye protection to guard against flying chips. Section 3, Drilling machines. Intro Tone, Direct and Instructional. Drilling machines are used to create round holes in materials using rotary cutting tools known as drill bits. 3.1 Types of drilling machines. Bench drill press, for light work and small parts. Pillar drill press, larger and more powerful, for heavy-duty work. Radial drilling machine, for large, heavy workpieces where the drill head moves over the material. 3.2 Common drilling operations. Drilling, creating a hole with a standard drill bit. Rimming, enlarging and smoothing an existing hole. Countersinking, creating a conical hole entry for flat head screws. Tapping, cutting internal threads. 3.3 Drilling safety. Clamp workpieces securely to avoid spinning. Keep hands away from the drill bit. Use appropriate speeds for different materials to prevent overheating. Section 4, Saws in machining. Tone, clear and concise. Sawing is often the first operation in machining, used to cut raw stock to size before further processing. 4.1 Types of saws. Band saw, continuous loop blade for cutting large or irregular shapes. Cold saw, circular blade with coolant to cut metals. Hacksaw, reciprocating blade for manual or powered cutting. 4.2 Sawing safety. Use the correct blade for the material. Keep hands clear of cutting zones. Maintain blade tension and sharpness. Section 5. Layout procedures. Before cutting, machining, or drilling, machinists mark out workpieces to guide operations. 5.1 Layout tools. Surface plates, perfectly flat reference surfaces. Scriber, for marking fine lines. Center punch, to make small dents for drill starting points. V-blocks, to hold round work during marking. 5.2 Layout best practices. Always measure twice before marking. Use light lines that can be easily removed after machining. Avoid scratching surfaces unnecessarily. Section 6. Introduction to CNC machining. Tone, modern and forward-looking. Computer numerical controlled CNC machining automates cutting operations using programmed instructions. Instead of manually moving the tool, the CNC machine follows a digital program to perform precise cuts. 6.1 Benefits of CNC machining. High precision and repeatability. Ability to produce complex shapes. Reduced human error. Efficient use of time and materials. 6.2 CNC Basics. CNC machines require a CAD design, digital model of the part. CAM software converts the design into machine-readable instructions, G-code. Machine setup, installing tools and work coding. Execution, the machine runs the program to produce the part. 6.3 CNC Safety. Keep clear of moving parts during operation. Never override safety interlocks. Ensure programs are simulated before running to prevent crashes. Section 7. Capability and safe use of machine tools. Tone, summarizing and reinforcing. Regardless of the machine tool, lathe, mill, drill, saw, or CNC, the same safety principles apply. Understand the tool and its limitations. Use the right tool for the job. Keep tools well maintained. Always follow safe working procedures. In this course, we have moved from safety and measurement fundamentals to practical machining operations. You now understand how to protect yourself and others in the shop, how to measure and mark work accurately, how different machines operate and how to use them effectively, the importance of both manual and CNC machining skills. By applying these principles, you can work with confidence, produce high-quality parts, and maintain a safe, efficient workshop environment.